I'm pretty stoked the first layer of those circles is sticking well. This is wild. This thing's even quieter than the Prusa. Comparing speed for speed. So I've run a very similar slicer profile to this on the Prusa many times, and yeah, I guess those polycarbonate wheels on the C-beams are quieter than the steel on steel of the linear rods or linear rails on the Prusa. And I should mention that overall this is quieter than the Prusa. However, that cooling fan on the heatsink for the hot end is pretty loud. I mean, it's always running full blast. It's definitely running at a higher RPM than the heatsink cooling fan on the Prusa because it's a smaller diameter. And something else I noticed about that, it's pretty out of balance. So with the effector up in the air and the nozzle not touching anything, there's quite a bit of vibration coming off of there. But when the nozzle's down and printing, it seems to dampen out that vibration pretty good. So room for improvement there. I seem to be developing some sort of a rattle. Can't quite identify where it's coming from yet. Actually, I'm not sure if that's a rattle or a bad bearing. All right, so despite a potentially failing bearing, these are the first non-test prints off the DERP. So these are 3 gantry mag ball mounts, but I plan to use these to actually drill and tap some extra gantry plates. That way I can get the full build diameter. So that will eliminate these parts from being mounted to the gantry, and I'll mount the mag balls directly to the gantry plates. So yeah, first utility type prints off the DERP will be used to upgrade and improve the DERP in true, I guess, rep fashion. So these aren't perfect, but not terrible either. I am quite happy with this. I think I found the source of that noise. Looks like it's just a little bit of slop in the eccentric adjuster for the gantry wheel. So one way to check that is you just put some side pressure, which will force one of the wheels in contact, and then you can try to wiggle the other side so it's on the top. And you can try it both ways, and if I try to fix the top and then wiggle the bottom, I have no play down there. So it's the top eccentric that I need to adjust. A quick mod to this open built wrench let me adjust the gantry eccentric nut in place. But this will do for now, and if I need to do more adjustment, I will take the top off and take the gantries all the way out. I've got these gantry plates set up to use as drill guides on 3 more C-beam gantry plates. So I plan to use a drill press to drill and tap these. That'll get me a little bit extra diameter on the build volume and a little bit lighter weight on the gantries. And next I decided a little calibration was in order. So I used Teaching Tech's GitHub calibration website to do some retraction testing. So on the left here, we've got PLA. And yeah, this is just Overture PLA that I got through Amazon. And this tower is 0 to 2.5 millimeters of retraction. So the bottom segment is no retraction. The next one is 0.5, and then 1, and then 1.5 is where it looks good, like no visible artifacts. And then the next one is 2, and the one on the very top is 2.5. But my initial prints were with 5 millimeters of retraction, which was just apparently way overkill. On the right here we have PETG, same thing, Overture through Amazon. And this retraction tower goes from 1 to, 3.5 in 0.5 millimeter increments. So the bottom is 1 millimeter of retraction, then 1.5, and then 2, and then 2.5 is the first good one with no visible artifacts. And then the next one is 3, and then the very top is 3.5. And based on the documentation for retraction settings, this is pretty decent. So longer Bowden setups need more retraction because they have more flex inside the longer PTFE tube. But because this PTFE tube is relatively short, it's only about a foot long, so 30 centimeters-ish long, it actually doesn't need that much. I mean, definitely more retraction than a direct drive, but definitely less than the documentation was stating for a Bowden setup. And here's my solution for the build plate clamps. So I'm now using one just static puck in the rear, and then I'm using 2 sets of these adjustable wedge clamps in the front. So one I will leave relatively static after having set it up, and then the other one will be the one that I can just loosen real quick and pull it out. 2 hands makes it easier because you can push down on it, but you don't need a ton of pressure here. Just a little finger snug. So there's a brass insert on this side, and then just a lock nut here, and then a couple of lock nuts for a makeshift thumb screw on this M3 stainless threaded rod, and that's working absolutely great so far.